So welcome. Thank you all for coming. Just to make sure everyone's in the right place, this is the Trail Master training for the Trail Survey program. So this is the more advanced level of participation. We're going to be going over 18 different species that you guys will be out in the field identifying for the whole summer. So if you signed up for the trail trackers or you wanted something a little like less intense or you wanted to start at the beginner level, we do have another trail tracker training coming up next Tuesday. But if everyone is in the right place, then we'll get started. And I will give people time to do this later on as well. But if you have not already done so, please download the Survey 123 app on your phone or tablet. Any mobile device will be walking through how to use it to survey and record invasive species observations so that I can go through them and when I receive them and see what you guys are reporting you found. It is in the previous years, if anyone participated before, we used to use IMAP invasives. Survey 123 is much more straightforward, so it should be a pretty easy process, and I'll walk over that in the second half of the presentation. But before getting into the bulk of it, just want to give a little bit of an overview of me and my job at the PRISM. So I'm the Invasive Species Project Coordinator at the Finger Lakes Partnership for Regional Invasive Species Management. This program in previous years has been run by my boss, Matt Gallo, but now I am running some of our volunteer programs and kind of helping out with a lot of our terrestrial work, including these, and also doing like field work and management and planning. But so as for the PRISM itself, we're one of 8 regional PRISMs in New York State. PRISMs are just a partnership between the DEC and some other environmental organization. In our case, that's the Finger Lakes Institute at Hobart and William Smith Colleges. So our PRISM encompasses this entire 17-county region in the Finger Lakes. We are the largest PRISM by area, and I recently realized that this is the size of New Jersey. So we have a lot of area to cover to look for invasive species, to determine how we should best be managing them, because we are like sort of the main organization in the region determining like kind of focused on invasive species education and management and planning. And so it's a lot of area with not that many people, which is why volunteer organizations or volunteer programs and participation by people like you is so important to us. So you are here for the Trail Masters program, so I'm sure a lot of you kind of already have a pretty good idea of what invasive species are and why we care about them so much. But I do just like to give a general overview of the most important concepts, just because it can sometimes be sort of a nebulous idea, especially when we hear about species like spotted lanternfly or kudzu or zebra mussels or Burmese python. Things that we're just like, we know that they're bad, but why, and what kind of makes them all fall into the same group. So the on-paper definition that we use of invasive species is any non-native species that causes harm to the environment, economy, or human health. It can do just one of those things, it can do all of them, but the two things that make something invasive without any other like qualifiers are they are non-native and they cause some sort of harm. Because there are plenty of things that do one or the other, but they don't do both. And it can be really difficult to predict if something is going to become invasive. We can't always look at something in its natural environment and figure out right away, oh, if it comes here, it's going to grow out of control and push out all of these other native species, or it's going to be really dangerous to this particular animal that we have. We can't really do that, and it can be hard to tell, but invasive species tend to have a lot of characteristics in common. So having a very high reproductive rate, eastern gray squirrels, which are native to us but very invasive over in the UK and Ireland, are just a prime example of an invasive species because they reproduce really quickly, they are able to grow in very large numbers, they act very aggressive. So with something like eastern gray squirrels, they terrorize the native squirrels over across the pond. They will like beat them up, push them out of their nests. But if it's something like a plant, maybe growing over other species, shading out ground cover, they have no natural predators, so you know they're spreading very quickly, they're acting very aggressive, and nothing is keeping those numbers down, so they can just keep like the population can just keep blowing up. If they're from a similar climate and latitude, so a lot of the invasive species that we get are from Europe and Asia because it's a similar 4-season like climate. more temperate conditions, something can come over here and have it be just like home, but nothing's trying to eat them the entire time. So they're able to just really thrive. But one of the biggest things that doesn't get talked about quite enough, but is like the kind of joining factor among most, if not all, invasive species, is that they are fantastic at taking advantage of human disturbance. If you saw in this picture right here, Japanese knotweed growing straight through pavement. That's because this species evolved to grow through like volcanic rock. So a lot of other species can't survive the kind of disturbances that we create, like paving over somewhere, but invasive species like Japanese knotweed can. So they're very good at adapting to the kinds of disturbances that humans create, whether it's suburban sprawl, parking lots, highways, deforestation, agriculture, anything like that that disturbs the environment. Invasive species are very capable of moving in and taking over. But how do things become invasive? How do they get here? How does it even get the opportunity to start causing those kinds of problems? And we have had invasive species introduced both intentionally and unintentionally. So overall, when I say intentional, I don't mean like someone wants it to become invasive, more just they brought it here on purpose. So people releasing pets because they, for example, like this goldfish over here, maybe a parent gets tired of taking care of their kid's fish and they think, oh, I'm just going to put it back into the wild, even if it's a wild it didn't originally come from. So they dump it in a lake or a pond and then they grow to the size of this monster. Plant imports for horticulture are another big one where we purposely bring something in that does really well in our gardens. It looks really, really pretty and it survives well and it spreads nicely, but that's how a lot of our invasive plants get introduced and start spreading. Or if we purposely introduce something maybe to control another invasive species or a native pest, biocontrols have gone wrong many times and we're much more careful with them now. But sometimes we introduce something thinking that it will take care of a problem for us by preying on whatever insect, for example, is like eating a crop that we care about or pushing out other insects. And it ends up becoming a bigger problem than what we introduced it to control in the first place. And then just some unintentional introductions. Invasive species a lot of the time are really good hitchhikers, so things that get picked up in like ballast water or hitch on propellers and then get moved from one place to another. Same with moving on like clothing, getting stuck in the crevices on your boots, and escapees as well. So Burmese pythons are a great example of this. Down in Florida, they are a huge problem because they were being bred in a pet mill. And in 2009, Hurricane Andrew came through, destroyed the pet mill, and they all got out into the wild. And now they are all over the place, and Florida literally pays people to go and kill them because they're such a problem. So all of these different ways that invasive species can get out into the environment and start causing problems, but it's really important to remember that this is not the majority. So the way that we kind of keep this in mind is through something called the TENS rule, and that is just only roughly 10% of non-native introductions will actually be able to survive in the wild and like established populations, and only a subsequent 10% of those survivors become invasive. So it's a very small minority of non-native species that actually start getting out of control and become invasive, but that minority has a gigantic impact. So when we talk about kind of the impacts and the costs, whether it's just in terms of those environmental, economic, and human health, or just looking at a pure money number, this is kind of the way we like to visualize it. This is called the invasion curve. And certainly not every species follows the same timeline and gets out of control and reaches this last very expensive stage at the same rate. But this is kind of a generalization. So as time progresses after the introduction of an invasive species, we have sort of a limited window of when we can spend the least amount of money to take care of it while there's very little of it and sort of prevent as much damage as possible. Unfortunately, we don't live in a perfect world where we could easily predict exactly what's going to become invasive, where it's going to come from, how big of a problem it would be. I would love it if we did. But so this prevention stage down here, as much as we like to do work there when we can, there's a lot of things that can just slip under the radar. So eradication and containment is kind of where we try to do a lot of our work because the species is not covering that much area. Therefore, we don't have to spend as much time, money, labor trying to take care of it. The public typically becomes aware of invasive species well into the containment stage, though. So the opportunity to do that and rely on volunteer support, for example, in the eradication stage is usually pretty low. And so a great deal of the invasive species that we have do eventually and are already in this asset-based protection and long-term management stage where the best we can do is just kind of protect what we have that is native. There's no way we're going to be able to get rid of it, and containing it is less reasonable as well. But those more specific categories that I talked about, environmental, economic, and human health. Some environmental losses that we might see. Invasive species are the second largest threat to biodiversity behind habitat loss, but they can also cause physical structural changes in the environment that change the way native species are able to interact. They can disrupt natural processes as well as ecosystem functions and services. So if something, for example, is invasive in a wetland and it changes the way that water moves through that system, that might affect our water quality and like flood buffering, something like that. Economics, agriculture is severely threatened by invasive species. Spotted lanternfly is a great example of this. In Pennsylvania, spotted lanternfly absolutely decimated their grape production, and it becomes very costly when things like that happen. But also recreation, infrastructure, trade, and management. So if something is physically damaging what we're putting our tax dollars into, or making it so that people can't go and use the spaces that we might like rely on economically, that has a big impact. It adds up over time. And then with human health, as our soil and our water and our air quality decrease, so does our quality of life. But also, giant hogweed is a good example of how invasive species can just cause physical injury to people as well. So not just by kind of indirectly impacting the environment, which impacts us, but directly by if we interact with it, it will harm us in some way. So all of these costs put together into a number. This is a conservative estimate, so on the low end, but the United Nations estimated last year that globally we spend roughly $400 billion on invasive species control every year, and that number has actually quadrupled every decade since the 70s. And it is kind of continuing in that pattern, unfortunately, so it is an exponentially growing problem, which is why it is so important that we act on invasive species as soon as possible, which brings me to the Trail Survey, which is why you're all here. So the Trail Survey is our terrestrial volunteer program for the summer. During the winter, we do the HWA program, and then as it warms up and we start seeing invasive plants come back, that's when we ask you guys to go out and survey. So as long as you have a smartphone or tablet, some sort of mobile device that can use Survey 123, you can participate. You can get your friends and family to participate. We are very happy if you do. And you can pick any trail in the Finger Lakes region to participate. Because you're in the Trail Masters program, we're going to ask you to survey the same trail in June, July, and August to monitor some changes. And you pick that trail, go and look for the list of species that I'm about to explain to you, and then just tell us what you find or what you don't find. So obviously caring about invasive species is important, but why specifically trails? Why do we even bother with the trail survey? Trails are the perfect kind of environment for invasive species to move into because they are frequently disturbed by foot traffic, from people hiking, by people mountain biking, or just from clearing like brush and debris for the safety of hikers and bikers. And like I mentioned before, invasive species are good hitchhikers, so they can easily be carried in on clothing, boots, like in bike wheels. It's very easy for them to be transported along trails or in or out of them. And forest edges especially are a very unique habitat because they get like more light, more wind, and like have more variation in temperature and moisture than other parts of the forest or like a field that is adjacent to the forest. And so that can make it pretty difficult for native species to survive as well along that edge as they might deeper into the woods or farther out in some field next to it, which makes it the perfect little area for invasive species to move into. But on the people side of things, community scientists like you guys are often the ones to discover invasive species for the first time in a region. So this example is from a couple years ago in Ohio. Some students doing a research project were the first people to identify spotted lanternfly in their county in Ohio. And this is what happens a lot of the time where it's not necessarily environmental professionals like me and my colleagues. It's people who are just out doing research or hiking or some sort of citizen science totally on their own because they care about it. So as for the actual survey protocol, you're just going to start hiking down the trail using the Survey 123 app to make observations. Once you come upon a species, if you do find one, stop and from that point where you see the species, look around an imaginary circle with a radius of 50 feet. And if you see not just that species, but any other species that you see in that area, report all of them. You won't have to make multiple different reports for the same point like you would have had to with IMAP invasives, if anyone used that before. It is all built into one form in Survey 123. So if you see multiple species in the same spot, tell us about those. If you don't find any, we also want to know that. So every 5 or so minutes of walking, if you're not finding any invasives, stop, take a point, and tell us which species were not there. And so like I said before, 1 trail per month minimum, but if you want to go out and pick a couple trails to survey in June, July, and August, you're welcome to do so. We are happy to accept any amount of data that you will give us. So before we get into how to use Survey 123, I'm going to go through our species list. There are 18 species on the list this year. And I have also highlighted in these slides the primary characteristic that we want to see in the pictures that you submit with your observations, because I'm going to go through all of the observations that get submitted to make sure that they're being properly identified. And so just picking that one very distinct characteristic and knowing what you're looking at makes it very helpful for us to be able to tell that it's correct. So starting off, autumn olive, this is a very well-established invasive species. A lot of you probably have it in your yard or have seen it along hiking trails. This is a perennial woody shrub that is native to China, Japan, and Korea. One big thing about it that's kind of unique is it's a nitrogen fixer. So it can turn nitrogen in the air into nitrogen in the soil. And that can negatively affect soil composition and like nutrient cycling, but it also just crowds out native species because it gets really big and bushy and shades the ground. So the identifying feature that we want to see for autumn olive is these, it's covered in, it's kind of hard to see, I think, in this picture when I'm screen sharing, but it's covered in these little silver dots, and the underside is very silvery as well. And then later in the like near the end of summer and in the fall, the berries that it produces, these like reddish orange berries, are also covered in those silver spots. So we want to see that. They're also kind of visible along the stems as well. But just some other identifying features. It looks very similar to honeysuckle in terms of like the leaf shape and and the flowers sometimes, but it has an alternate leaf arrangement. So the leaves don't grow out of the stem in pairs. They kind of take turns on each side. Next up, black and pale swallowwort. Everyone has probably seen these. This is also very well established. You don't need to distinguish between black and pale swallowwort when you are reporting them. We just have them in there as the same species because if they don't have the flowers out, it's really hard to tell the difference. So this is a perennial vine that is native to Europe and will creep over fields, over trees. It'll even grow all over itself and crowd out native plants by shading the ground or just growing straight over them. But it is also closely related to milkweed and looks very similar to milkweed, which is the exclusive food source for monarch butterflies. And so they will land on it, lay their eggs there, and then when the caterpillars hatch, they start feeding on the swallowwort, and swallowwort is toxic to monarch caterpillars. So a big part of the reason that monarchs are endangered is because they are mistakenly laying their eggs on this invasive, and it is killing the caterpillars before they can grow up into butterflies and lay more eggs. So the way that we want to be able to identify swallowwort in the pictures you submit are, it's got these long with a simple leaf margin, these long pointed opposite leaves, so they're growing in pairs along the stem, and these small star-shaped flowers. If the flowers aren't out, then the seed pods might be out. They're kind of like long and thin, look like green beans, but the leaves and the vine will likely be enough if the flowers aren't there. Pale swallowwort has these like pale pink ones, and black swallowwort has like darker black purplish flowers, but they're shaped like little stars. And I should also mention, you don't have to like remember all of this off the top of your head. I will be providing you with a cheat sheet to like show you all of the identifying features that we want you to remember to take pictures of. So you can refer back to it later when you're making your observations. Moving on to beech leaf disease. This is an emerging invasive species. This is one that I wish I could give you a lot of information about, but unfortunately there is a lot that we don't know about it. We know that it is caused by a microscopic nematode called Littlelenchus crenati macanii, but we don't know where it's from. We don't know how it got introduced. We have no idea even, well, we're not completely sure even how it spreads because we don't know if it's the nematode itself that is causing the disease or if it's a virus that it carries or something else. But we do know that when it's present, it leads to this dark striping on beech leaves, and it will eventually leads to leaf warping, defoliation, and eventually can kill off beech trees of all ages. So unlike beech bark disease, which only affects adults, it will also affect saplings as well, so they don't have time to regenerate in between like infections. So really the main characteristic, or the only characteristic that you can send us a picture of to show that it's beech leaf disease is these dark stripes that appear when you hold the leaf up to the light. And make sure that you are holding it up to the light to take the picture, because it's pretty easy to like look at it from the top with the like shadow or ground behind it and not see those stripes. But so if you're checking beech leaves, definitely look with the light behind them. And also just a note on other things that can make beeches sick. A healthy beech is going to have like nice smooth leaves. It doesn't have those dark stripes, and they're even, they're not warped like that, and this smooth silvery white bark. But beech trees can get sick with other things like beech bark disease, which causes this kind of like gnarly chipping away look. But also they're prone to some fungal infections, like this I believe is called anthracnose, which also affects the leaves, but does not cause that same characteristic banding. So if you see something like this where they're turning brown or they're yellowing or drooping, that is probably not beech leaf disease. The main characteristic that we really do want to see is those dark stripes when you held up to the light. Moving on to Callery or Bradford pear. This is very well established in terms of like it is planted in a lot of places. In terms of like getting out into the wild and being understood as an invasive, it is kind of more on the emerging side. I'm sure that everybody has seen one in a Wegmans parking lot, or I went to RIT. There were plenty of Callery pears on RIT's campus. So this is a medium to large deciduous tree native to China and Vietnam. These are very, very susceptible to storm damage and like wind damage. So even if it's not dropping branches, which it does very easily, they can just get bent and disfigured and end up toppling pretty easily. But they also spread very aggressively. So if they are able to establish like on the edges of farm fields, they will very readily just spread outward and crowd out native trees as well. The other thing about Callery pears, if anyone has ever encountered this, they smell really, really bad because they are pollinated primarily by flies and not by like bees and other things that like sweet stuff. And so they evolved to imitate the smell of like rotting things because that attracts the flies more than something sweet like other flowers. So the main way to identify Callery pear, later in the season, it's very easy to figure it out because they have these little tiny reddish brown fruits that have pale dots all over them. but those won't appear until later in the summer. So before that, the main thing that we want to see is the bark. So on younger trees, it will be smooth and very silvery, but as it gets older, it develops these brown fissures and this kind of like almost like vertical, like striped appearance. So that's what we want to see a picture of, but you can also tell that it's Calliopera if it has these white flowers with 5 leaves and also these kind of rounded green leaves with serrated margins, like finely serrated margins. Chocolate vine. This is one of my personal favorites. I really like this plant. I'm very sad that it's invasive because it is just so cute. It's really pretty. This is an emerging invasive species that is on our early detection list, both for you guys and for our terrestrial team as well this summer, our terrestrial technicians. This is a perennial woody vine that is native to China, Japan, and Korea. It will not grow very high, is something that we have found is pretty interesting, but it will absolutely blanket ground vegetation, shrubs, anything that is short enough that it can climb over it and wrap its like vines around sort of thinner material. It will easily do that, which blocks sunlight and prevents like the growth of smaller plants underneath and outcompetes the like existing plants that are there by just overly shading them. It's very distinct. There's nothing that looks like it in our region. So it's got these compound leaves with like 5 oval leaflets that all have little notches at the tip. So that's the main thing that we want to see in the pictures. But if the flowers are still out when you do go and survey and you find it, the flowers are very distinct as well. They're these maroon, like reddish, purplish brown color that are like drooping and kind of cup-shaped. And it doesn't appear, like I mentioned before, to get very high. So if you do find it, it will likely be either covering lower things or growing somewhere like in a trellis or on the side of a building that has a grate on it. This is at Cornell University. We're well aware of the invasive species or the chocolate vine populations over there. This is me for scale next to this gigantic wall of chocolate vine. And when we found it, it kind of surprised us because when we had found it elsewhere on the campus, it was just growing over this other like short stuff. Even the well-established like honeysuckle, autumn olive, other invasive species, it was growing over all of that, but it wasn't growing up in anything tall. And then we realized that it's because this entire structure is one big grate, so it's got lots of little spaces to wrap its very thin vines into. So I don't know that you'll necessarily find an infestation this large on a trail. I just think that it's pretty neat that it does that. Common buckthorn is our next species. This is very well established. You've all probably seen it. This is a woody perennial shrub that is native to Europe and West Asia. It gets its name, Rhamnus cathartica, from the fact that the berries have a very strong laxative effect, so they contain a cathartic agent. And so because of this, don't eat them, but also just don't eat any berries if you don't know what they are. But then when like native birds or other native species eat the berries, it can cause that very extreme laxative effect. And if it's the only thing there for them to feed on, because it's pushed out all of the other native species or native plant species, then eventually they will become malnourished or severely dehydrated and die. But it also shades out native ground cover plants that can help control runoff, especially because buckthorn likes to grow in like wetter areas. So having those lower ground cover plants that help deal with like water management sort of is really important, and buckthorn prevents those from being able to thrive. The main identifying feature that we want to see when you submit buckthorn observations is this long, very sharp thorn that grows in between the 2 leaves at the end of each twig. So it'll, if it's earlier in the season, which right now all of the leaves should be out, but before the leaves grow out, that's what the end of the twigs look like in this middle picture. But it's still very visible at the end of the twigs once the leaves are out. It also has this like bright yellow core. So if you happen to carry a pocket knife with you and you see something that you think is buckthorn and you're not confident based on the vegetative properties that you see, you can just cut off some of the bark, and if it has this bright yellow core on the inside, that's another good indicator. So we'll also happily take that as an identifying feature. But the leaves they're very dark green. They've got very fine teeth along the edges, and they have deep leaf veins that go sort of parallel to the mid vein up towards the top of like the edge of the leaf at the top. And then those blackberries, which develop much later in the season. Next is European dewberry. This is pretty early emerging invasive species. There have only really been observations of it kind of around Rochester and Syracuse. But so this is a perennial herbaceous shrub that is native to Europe and Asia. The impacts of it are sort of similar to like the inconveniences that we get from other brambles, where like, if there's a very large patch of raspberries or blackberries or anything with thorns, trying to get through that is really difficult. And so both for us or for like some native fauna trying to move through that space. So it grows in these very thick thorny patches that impede movement but also shade out native plants growing under it. The main thing that sets them apart from other aggregate berries, because there are a lot of things that look very similar in terms of leaves to European dewberry, are these berries are like a dark bluish black, and they have this gray, like waxy bloom on them. So that's what we really want to see a picture of, because it will be much harder to identify that is definitely dewberry just based on the leaves. So if the berries are there, send us a picture of the berries. If not, it has palmate compound leaves with 3 leaflets coming out, and they are alternately arranged on the stem, and the stem is covered in these prickles. It's kind of hard to see in this picture, but the stems are taking turns coming out of the main stem growing out of the ground. Up next, Japanese barberry, also very well established. I know that there's some growing right in front of my parents' house. This was a very popular ornamental plant, which you can no longer buy in New York State, but it is definitely still here and probably to stay. This is a woody perennial shrub that is native to Japan and other parts of East Asia. When it is able to access forest and edge habitats, it really like becomes dominant in those areas, pushing out native plants and just really populating that forest tree line. It has this really distinct, when it gets enough sun, like bright burgundy color, but if it's growing in a shadier area, like in the middle of the woods, it might not have that. It might revert to green coloring. So the main identifying feature for Japanese barberry that we want to see are these whorled leaves that grow in clusters that are kind of facing upward, and they've got this unique spatula shape where they're very thin, closer to the stem, and then they sort of fan out farther away. But they also produce these drooping yellow, like very little flowers, and then much later in the season they produce red berries. So regardless of whether it's red or green, keep an eye out for those whorled spatula-shaped leaves. Japanese knotweed, I talked a little bit about this one before, but it is very well established in our region. This is an herbaceous perennial. It looks a lot like bamboo, but it is not woody in that same way. And it is native to Japan, China, and Korea. So, like I said before, it is very, very resilient because it evolved to grow in like volcanic rock. So it forms these really tall, really dense thickets that shade out anything underneath it. It can grow in pretty much any conditions. There's not really anything we can throw at it that will make it not want to grow there. And so because it just forms these walls that are basically impossible to move through, that reduces the habitat for native fauna, and it can also damage a lot of different infrastructure because it is just so willing to grow anywhere. The leaves are pretty big, so that's the main identifier. They're probably about the size of your hand. They're broad, either heart or like spade shaped, and they grow on a zigzag stem, alternating along the stem with like zigzag nodes. And the stems farther down, if you can't get like a good picture of the leaves, have these reddish and purple spots all over them. They're mostly green, but with that reddish and purple coloration on them as well. Later in the season, they'll also develop these like strands of yellowish white flowers, but those will probably not emerge until after our season is over. So we really want to see these broad green heart-shaped leaves. Japanese stilt grass, another emerging invasive. This is an annual grass that is native to most of Asia. It is another one that I really like because I think it is very, very cute and makes me sad that it's invasive. But so it's this very delicate, like feathery grass that emerges earlier than other grasses and stays later than other grasses. So it kind of outgrows native grasses on both sides of the season and reduces the availability of food resources for species that feed on grass because nothing is going to eat it. Even deer won't eat it, which is a pretty low bar. So the main identifying feature that we want to see with Japanese siltgrass is this silver stripe that it has up the middle. It's very distinct. It looks similar to other grasses because all grasses look pretty close, but no other grass has that silver line up the middle. But another way to tell that it's stiltgrass is because the roots are the reason it's called that. They kind of prop the plant up on little legs. They're very thin and delicate. It's very poorly rooted, so it can also be very easily torn up. And these roots will kind of splay out because they can emerge from any node along the stem, and it creates that sort of propped up appearance on stilts. But the silver stripe is what we really want to see in your photo submissions. Myelominate, another emerging invasive species. This is native to South and East Asia. It's also an annual vine. Similar to Japanese stiltgrass, very poorly rooted. You can pull it up very easily, but it grows like crazy. It will blanket other plants. It does not care how tall something is the way chocolate vine does. It will just, it's got these like sharp hooks along the stem that it uses to climb very high and blanket pretty much anything in its path, and it can grow up to 6 inches per day. So it gets very bulky, very heavy, and like weighs down anything that it is growing on top of, making it impossible for anything else to grow underneath with that lack of sunlight, and also deforming, especially like young trees that just can't support that much weight. It has very distinct leaves with these nice, almost perfect equilateral triangles. So if you send us a picture of that, we'll automatically know that's myelominate. But along the stem at nodes, it also has these circular leaf structures called ochrea. And that is a very unique feature to myelominate, so that's another good distinguishing feature. So the leaves or the ochrea will make it very clear to us in your submission that that's myelominate. But there are also these like hooks on stems that if you're going to touch the plant or pull it up, definitely wear gloves because they can cut you up pretty badly. And then later in the season, they'll produce this bright blue purplish fruit that really stands out. Norway maple, some of you might have Norway maple in your yard. I know that on campus at Hobart and William Smith, there are plenty of them planted along the street. This is another very popular ornamental tree. Medium to large deciduous tree that is native to Europe. It's a very aggressive invader, so it will outcompete native maples, and we have a lot of native maples around here. This is the only, well, one of two non-native invasive maple species that are sort of putting additional stress on our maples. When you see them out in the wild, they will, if they have spread from a tree that was planted, they will usually be green. But the ones that are planted, this is called the Crimson King variety. Usually the ones that get planted ornamentally or like as a street tree have been bred to have this like purple coloration. So they have typical maple leaves, which can make them kind of hard to tell apart from other maples, but their really distinct characteristic is when you break the leaf off, it'll produce this milky white sap. Native maples produce a clear sap, so there's nothing else that could be mistaken for a Norway maple. And the bark is also not shaggy like native maple bark is. So just for some comparison, sugar maple and red maple on the left and the right both have this kind of shaggy, like flakier appearance, and the bark looks like it would be easier to peel off, whereas Norway maple has more ridges and furrows and doesn't have that same flaky, peely, like shaggy look to it. Oak wilt, another emerging invasive, really, really bad for oak trees. Just like with beech leaf disease, we don't know where this came from, but we do know that it is spread by nitidulid beetles. Not great with that word. So the main way that we are encouraging people to prevent oak wilt is by only pruning your trees when these beetles are not going to be out. So pruning in like the fall and winter, because the beetles are very strongly attracted to the sap of the oak trees when they're pruned, and then they move between the trees and they spread this disease if it's present on one that they go to feed on. So this is a fungal disease, and it basically just destroys the systems within the oak tree that move water up and down, like the body of the tree, and this leads to discoloration of the leaves, defoliation, and eventually death, and it can kill an entire oak forest within only a few years. White oaks are a little bit more resistant and can sometimes survive it, or like last a little bit longer. Red oaks always die when they are infected with oak wilt. There is no known cure for oak wilt disease, so it's really important to kind of get ahead on it when we can. So to look for oak wilt, look for this browning around the edges of the leaves. That is not, your characteristic autumn browning, something that should not be happening this time of year. And so just sort of like slowly progressing towards the center of the leaf. On red oaks, it will also produce these fungal mats underneath the bark, but those are hard to find unless you're peeling the bark off of the tree or looking very closely between the crevices. So those browning leaves are going to be what we want you to submit a picture of. Privet, this is also pretty well established. This was another ornamental shrub similar to autumn olive and honeysuckle. This is a perennial woody shrub native to Europe, North Africa, and Asia. This displaces a lot of native forest vegetation, and similar to a lot of the other shrubs we've talked about, it shades out ground covers, but it also produces a really large seed bank that leads to years of removal effort. So even if we do manage to remove the established shrub, which digging shrubs up can be a huge pain, we do still have to keep going back year over year to dig up more and more baby shrubs because it produces so many seeds. Privet is a pretty boring looking plant when it doesn't have its flowers out. It produces just these smooth, dark green, simple leaves that grow opposite of each other. And they don't have a hollow stem, which I point out because I'm talking about honeysuckle next. But so they will also produce these little white flowers. The flower buds are pretty distinct, so those would actually also be something that is good to submit a photo of to determine that it's privet. But the main thing that we want to see is those like erect branches that stand up pretty straight with the smooth, simple opposite leaves, and the not having a hollow stem, because that way we can distinguish it from honeysuckle. It's also one of the many plants that produces blackberries later in the season, but those will probably not show up until after we're asking you to look for these. Honeysuckle looks pretty similar to privet, but has lighter, softer, not quite as shiny leaves. This is also a perennial woody shrub native to the same regions as privet. And I should say both for privet and honeysuckle, there are a lot of different species that are pretty much impossible to tell apart from each other unless you are getting like really, really in depth. And we don't want to ask you guys to do that. So these are both lumped in as just privet species and like honeysuckle species, because native honeysuckles are very difficult to find around here, and they mostly occur down south. So as I was saying, similar effect to the other non-native or invasive shrubs we've talked about. These crowd out native shrubs and ground covers, also like tree seedlings and like spring ephemerals, and eventually honeysuckle in particular will create pretty dense monocultures of just huge areas covered in only honeysuckle. Honeysuckle stems are hollow on the twigs, so if you find something that looks like this with those simple opposite leaves that are that nice oval shape, You can distinguish it if you're not already sure. You can distinguish honeysuckle from privet by checking the stem, just breaking it off. If it's hollow, then it's honeysuckle, and if it's not, it's privet. So send us a picture of these distinct, long, tubular honeysuckle flowers and that hollow stem so that we can verify it. And then later in the season, it does also produce these bright red berries. Spotted lanternfly, very newsworthy invasive species. Everyone has, if they haven't seen it, they've heard about it on the news. It's all over all the time. They are emerging in our region. There are populations established in Ithaca, Binghamton, and around Syracuse, and it was just identified in Monroe County around Rochester for the first time in October. So these are native to China and Vietnam, especially in August is when you're going to want to look for the easier to find versions of it. But it's a plant hopper species that absolutely loves anything sweet. So it won't feed on just any plant, but plants such as grapes, apple trees, hops, stone fruits, anything that produces sweet sap, they are swarm feeders, so they will just cover the entire plant with like 400 to 500 spotted lanternflies and suck the sap out of it, and then they excrete sugary waste called honeydew that then encourages fungal growth and disease and can kill off that plant. Spotted lanternfly is more so an economic pest than an environmental pest. So our bigger concern with it is agriculture because the Finger Lakes region, we produce a lot of wine, a lot of beer, cider, stone fruits, all of the stuff that spotted lanternfly absolutely loves. Because it's so distinct, there's really nothing that looks like it in our region. It's just that it can be pretty hard to find because they're very little and very sneaky. So any pictures of any of these identifying features, as long as they're nice and clear, will do. So if you find the eggs, they are going to look like they kind of have this like smooth mud-like coating over them, like grayish brown. There are four instars of nymphs. So the first nymphs, after they emerge from those eggs, starting in May and throughout like June, are very, very tiny, like smaller than a pencil eraser, and pure black with white spots. And then the next two instars are just that but bigger, and then the fourth instar is black and red with the bright white spots. And so getting later into the summer is when you'll start seeing those easier to find instars. And then the adults, which everyone's probably seen before on the news or my news feed is constantly full of spotted lanternflies from like all over the country. The adults are about an inch long. They've got black spots instead of white spots, and they have these really bright red hind wings that make it pretty easy to distinguish. They've also got a tiny little black head. So any of these life stages of spotted lanternfly, we definitely want to know because they're very high priority for our region. Sticky sage, an emerging invasive. These are herbaceous perennials that are native to Central and East Europe and West Asia. They're in like the salvia family, so they look pretty similar to some other salvias, but the name is very fitting. They are very sticky, so when you walk through them, they can easily hitch a ride on your pants, or if like a deer or some other animal were to cross through, same thing, get carried that way. The only known population in our region is out at Colgate University, and it is enormous. It just is absolutely blanketing the woods that it is located in. And these decrease plant biodiversity by just shading out other ground cover plants because of just how densely they will grow together. And they're pretty bushy, they get pretty tall, so they easily smother other vegetation. Like everything else in the salvia family, they have these square stems. So if you can get a nice up close picture, if you find sticky sage, of square stems that are covered in sticky little hairs, that's exactly what we want to see. But also these yellow flowers, kind of in this like C shape that are also covered in those fine hairs on very tall stalks. They stick up pretty high over the plant. And then the leaves are very serrated, and they are alternately arranged or oppositely arranged on the stem and kind of this like spade shape with these two points at the back. But the biggest thing that we want to see is those sticky hairs along that square stem. And then our last species, tree of heaven. This has been around for a long time. It's been in the United States since like the 1700s. This is native to China. It's a deciduous tree. And, prior to spotted lanternfly arriving in the United States, it was more just a nuisance. It wasn't really causing as much like problem as some of the other invasive plants that we have because it grows in like parking lots and areas that are already not really populated by native species anyway. It doesn't really invade forests in the same way that some other species do. But it turns out that tree of heaven is the preferred host species for spotted lanternfly in its native range. So when it got here in 2014, it just automatically had like these bases of operation pretty much all over the place because tree of heaven is very difficult to control and had grown just everywhere. So the way that you identify tree of heaven, and if you do find tree of heaven, definitely check it thoroughly for spotted lanternfly as well. But the way that you identify it is it has these glandular teeth at the base of the leaves. So it's got a mostly smooth leaf margin with these just like one or two little nubs kind of down at the bottom. When you break the leaves off, it creates like a U-shaped leaf scar that is pretty clearly like curved. And the bark on the adult trees looks a lot like cantaloupe skin. This isn't the best picture. It kind of shows it, but when they're like really, really old, it really just looks like a cantaloupe and it feels that smooth as well. And you can't send us a picture of this, but if you're not sure if it's tree of heaven, break it off and smell it. It smells kind of like burning peanut butter. It is a very, very unpleasant smell, but that will give it away because there's nothing else that smells quite like that. So those are all of the species that we want you to identify. And you're going to do so using Survey 123, which I talked about before. So I'll give people another minute. If you haven't downloaded Survey 123, please go ahead and do so. And I just ask that everyone kind of walk through filling out the form once. You don't have to submit it, but I'm going to walk through it with you. Very straightforward and easy, but just to make sure that everyone knows what to do. And I'll leave this up for a minute, but once you have the Survey 123 app installed, I don't know why they make the button so small, but when you open the app, it will present you with this login screen. You don't have to make an account or manage your ArcGIS connections. Just hit continue without signing in under those two buttons, and it will bring you to your home screen. And when you, up in the search bar, you'll see this little QR code icon at the end, and then you're going to use that to scan this code. Don't scan the code using the QR code that's or the QR scanner that's just built into your phone camera. Do it through the app or else it's not going to work properly. So if people just want to give like a thumbs up in the chat when they've done that, okay, I'll just give one more minute for people to do that, but it seems like it's going pretty well. Great, okay, so looks like, and if you have any questions, I will stick around for as long as you need to help with Survey 123. Janice, after you press the QR code button on that search bar, then just hold up your camera and hold it over the code that's on the screen right now, and it should open the survey in the app. Okay, so moving on to using the form, because it looks like almost everyone is good. When you first scan the form, it's going to like open it up, but when you are going back to get it later, this is what it's going to look like on your homepage. And when you click on that Trail Survey Program Observations, it's going to bring up this. So to make an observation, you're just going to hit the collect button down there. You can make observations without being connected to internet or cell service. So if you don't have service, it's just going to save it to your outbox. And when it does that, you do have to go in later and tell it to submit those, but you can just queue up a bunch of observations if you're out in the middle of the woods with no service and still submit them to us later just fine. And then to see your previous observations, just press that sent button and look back at whatever you've sent in. You can't edit them after they're submitted, but you can look through them. So this is what the form looks like. It is very straightforward. We tried to streamline it as much as possible. If any of you used IMAP invasives, like I mentioned before, it is much less user-friendly. So our goal was making it as easy as possible for you guys to use it. So you're going to create a new observation for each point that you're reporting. You don't have to make a new observation for each species. And I'll go over that in 1 second. So before moving to your next location, in that 50-foot radius that I talked about before, record all of the species that are present there and the details about them that we want you to fill out before moving to your next location so that it collects accurate GPS data about where those species are located so we know where to find them.
Neil,
Yeah?
do we have to fill in and create an account before we do any of this?
No. So on that startup screen, I don't know why they make this button so small, but you can just hit continue without signing in below those two first options, and that should take you right to the screen with the QR code scanner, or with the search bar to scan the QR code.
All right, thanks.
So another note on survey location before getting into the like observation details. If your GPS location is not like accurate down to below 10 meters, it will give you this like little yellow warning. If that does happen, you can still submit your observation. This is just something that we put in for ourselves because we do end up submitting all of this data to the IMAP invasives database. And so we just like to know how accurate the data we're submitting to the folks at IMAP is. Like when we give it to them, you can try to collect more accurate GPS data if you hit this little crosshair button, but we don't want people to be limited by their device capabilities. So if it can't get more accurate than that, don't worry about it. Still submit your observation because we still want to know what you're seeing or not seeing. So if you find something, you're going to hit yes under did you detect an invasive species, and that is going to pull up this little section. It'll create a little section that says species list with a little plus sign. You're going to hit the plus sign, and that will give you this form to fill out with information about the species you detected, the population size, and the distribution. So those options are just that full list of the species, population size less than half an acre or up to half an acre, like half to 1 acres, more than 1 acres. And then distribution, trace, sparse, dense, monoculture, or linearly scattered. And then for your observation photos, just make sure that we can clearly see that identifying feature of whatever species I mentioned before. And try to keep the picture in focus so it's not blurry or anything, so that we can identify for sure that it is that plant. So if you're observing just one species in a point, then you're all good. But if you see another one, you're going to hit this plus sign right here, and it will add that first species that you saw to this list and keep track of it up here. and then you can fill out that form again for as many of the species as you find. And you can see all of the ones that you have added to your list of observations up here at the top, so you don't have to worry about making sure that they actually got recorded. So you just fill out that same information all within the same point, so you don't have to go back out and make a new point for every single species that you observe. And so you can also go back through your observations if you need to edit them or just see what you've put so far if you hit the little arrow right here. And then you can also, if you mistakenly make an observation, hit the little garbage can to get rid of that one, and it'll only delete the one that you're looking at. It won't delete your entire list of observations. So if you see a species, fill out that section of the form, hit yes when it asks, did you detect something, and then just go through these steps. And that's it for detections. But we do also want to know what you aren't seeing. So for every point that you take, detections and non-detections, those 5-minute intervals, we want you to fill out this question of which species were not present. So filling out this kind of data in IMAP invasives was also pretty difficult because you would have to make multiple separate points for each of the species that you didn't find. So we tried to make it as straightforward as possible by just giving you this big list. So if you found a species on this list, don't include it in this section. But if you are making a point saying, I didn't find anything here, just select everything on the list that you didn't see, and it'll create that long list in this little section, and that's all good. Or basically just kind of like fill in the blanks, I guess, of what you observed versus didn't. So either fill out the entire, like check every single box if you haven't seen anything, or only the ones that weren't present if you did see something. And that's it. That's the entire form. Tried to keep it nice, sweet, and simple. And if you need any additional help with it, absolutely like ask me questions. But it seems like using it has gone better this year than it has in previous years with IMAP invasives. So this is all we need you to do. And like I said, like you pick a trail somewhere in the region and go and do this survey protocol at that same trail once in June, July, and August, looking for all of these species the entire time.
Camille, I just have a question on the trail. First of all, can it be on private land along an ag field and along a creek?
Yeah, any trail that falls within the Finger Lakes region.
And how long should the trail be? Any-
That is also up to you. If you want to do like several miles, go ahead. If it's a trail that's like a quarter to half a mile, that's also fine.
Okay, and then just pick a point and then go every 50 feet and pick another point. Is that what, is that something like that?
So for the like regular intervals, every 5 or so minutes of walking. The 50
5
feet
minutes.
is for if you do observe something, looking around from that point that you observe something for any other species that
Right.
might be in the same area as that one.
Okay,
But if you're not seeing anything, just check-ins every 5 minutes.
okay, thanks.
So identifying species, even with the cheat sheet that I'm going to give you and that whole long presentation, can sometimes still be difficult. So I would highly recommend downloading the Seek app. You just point your camera at whatever you're looking at, and it will do its best to tell you what it's looking at. It's very useful. It can usually, at the very least, like get down to genus or family. But I have this app. I use it all the time just for fun to see what things are. It's very useful for identifying species if you're not quite sure where to start. But so just to finish this out, sorry we went a couple minutes over. I saw this article pop up in my feed, and I thought that it would be very poignant to add into our presentation called "What is Citizen Science?" And other than like the actual definition of citizen science, the thing that I want to bring up is that citizen science is really the backbone of a lot of the work that we do in the invasive species world. So this is from our winter program, the HWA survey. All of these yellow points are observations that were present in IMAP before the season, and all of these like red and blue observations were made by our volunteers, especially like out in Madison County. We had a lot of people out there working, and they're filling in data gaps, finding new populations that we didn't know existed until they went out and reported them, or confirming that areas like Madison County don't have HWA yet. Volunteers like them and like you guys are so important to being able to do the kind of work that I do and that my colleagues do. And so just not even just within the Finger Lakes region, but like all over the world, all throughout the US, whether it's part of an organized program or just using IMAP invasives or iNaturalist to go out and survey. Observations from people like you guys make it so that we know what to do, where to do it, and it helps inform the best stewardship for our region and lets us sort of focus our limited resources in the right places. And we wouldn't be able to do a lot of that work without contributions from volunteers like you. So I just want to give a big thank you and make sure that you guys all know that every amount of data that you submit, whether you only survey one trail, whether you survey a ton, every observation helps, and you are a huge part of being able to support the environment of the Finger Lakes region like we do at the Finger Lakes PRISM. So thank you again. It is really, really important what you're all doing, and we appreciate so much your participation. But so that's all I have. If there are any questions, I'll stick around as long as you need to help answer them. If not, I will be following up with a detailed walkthrough of Survey 123 just to make sure that everybody like has those instructions on hand if they need them, and also a cheat sheet with those identifying features so that you know what to look for and you don't have to try to remember everything off the top of your head.
So I have a question about going back to opening the app. Well, I open the app and then I continue